Here we have another fluid flow problem through a narrow tube. The fluid flow is of course viscous. The setup that I have drawn over here might be a little familiar with you because we had solved a similar problem where the fluid was not viscous. Okay, so let me first explain what is happening over here. This narrow tube contains a liquid inside it, and the coefficient of viscosity of this liquid is equal to eta. The density of the liquid inside is equal to rho. Now what is done is, at one end of the narrow tube, a piston is fixed. Okay, this end is of course open. The cross section of the tube is circular in nature and the radius is as given as r. The length of the tube is equal to a. Initially the piston is at the left end, and now what is done is a force F is applied onto the piston towards the right. As a result, what would happen? The fluid would start coming out. It is observed that the force is applied in such a manner that the fluid comes out with a constant velocity of V0. I hope you understand. See, as the piston is moved, at one point of time, the piston would be somewhere over here, let's say. Okay. So, the position of the piston would keep on varying. As the piston moves towards the right, it is seen that the velocity with which the fluid is coming out is equal to V0, which is a constant. So, the force may be varying, may be constant. You have to determine that. What you have to do is, you have to find out the applied force as a function of the distance from the open end. If I say that the distance from the open end at any instant is x, then you have to find out the force as a function of x. Okay. You also need to find out what is the total work done by the force in moving this entire liquid out of the cylinder. You also need to find out what is the total work done against viscous force. So the work done may have a number of components. What you have to do is, you have to find out the work done against viscous force. It's a very, very simple problem. Try this problem out by yourself. If you are not able to solve it, the solutions are coming up in the follow-up videos. Thank you.